My paper is introduced within the 19th International Conference on Intelligent Systems Design and Applications. Dear attendees, this paper is named Dataset for Intrusion Detection in Mobile Ad-Hoc Networks. This is me, Rahman Middib, who's going to present it in front of you. This work has been co-supervised by Dr. Bayram Triki, Dr. Farah Jamili, and Professor Wajdi Gorba. All of them, they do belong to the Mars Research Lab in the Higher Institute of Computer Science and Telecom, University of Sousse in Indonesia. As for our plan, it's divided into 7 main parts: the introduction, network-based IDS's problem statement. Then we move to the optimization model ideas for MANET. Later, we're going to spotlight on the dataset generation process and the dataset evaluation. And finally, we're going to end up with the experiments and the result, and finishing with a conclusion. The advantages of MANETs are the following: rapid deployable, self-configurable, and they do not require any infrastructure to work. As for the challenges of MANET, they are the following: less infrastructure, dynamically changing typologies, limitations of physical layer, limitations of mobile nodes, and network security. It's noteworthy to say that the vulnerabilities of mobile ad-hoc networks are subject to numerous kinds of attacks. As for the network-based IDSs for the problem statement, there is no clear line of security, and the malicious node can quickly attack and perform some malicious behavior, which is hard and difficult to detect, since MANET will require more safety or more security scheme to ensure its communications. There are several IDSs which were developed and dedicated to the wired network. Nonetheless, these systems cannot be used with MANET because of their complicated network properties. Network-based intrusion detection system is the most efficient way to defend against attacks in MANET. As for the suggested architecture for optimization model IDS for MANET, it aims to create a standardized process for generating quality IDS datasets, and also a high-quality evaluation datasets that can be used for machine learning analysis. Two of the main contributions are discussed to ensure high intrusion detection. The first one is related to data collection, which is aimed at detecting intruders. As for the second one, it lies in utilizing a machine learning algorithm for an evaluation dataset. This process focuses on data collection mechanisms and the generation of the attack scenarios. It is made of the following components: the data collection training module, which is responsible for collecting traffic data in a mobile network. Second, the data pre-processing module, which is effective for obtaining relevant features. And finally, the fuzzy signature module, which is reliable for analyzing the collected data against suspicious activities, defining the class labels and the patterns of a signature. During the data collection process, the network cannot guarantee the same route to reach the selected destination route. Therefore, some supplementary nodes are required. These IDS nodes are supposed to be protected in order to trust the integrity of the collected data. The specific node is used as both the routing node and the data collection node. It collects the data in the form of node and network characteristic values. A dataset forms a dataset that contains all traffic that goes through the network. In this due, we propose to define a typical dataset, a thorough investigation of attacks, and a selection of the most recent DOS attacks against MANET. The study will be limited to 4 types of attacks: 2 attacks fit into packet dropping category, black hole B and gray hole G. One attack that fits into routing disruption, wormhole W. One last attack is included in the resource consumption, flooding F. It defines the relevant features of the data preprocessing method which are applied to these features. A previous and necessary step is to know which features must be considered to calculate the final evaluation by the IDS node. The feature selection is required to obtain the impact of the malicious node on routing behavior. In mobile network topology, we select suitable performance metrics according to each requirement defined by the fuzzy inference system. Uses the Mandani type to explain the behavior of the system of a node. The average data packet drop rate, the packet delivery ratio, the sequence number, and the hop account. They are used as input parameters, and the variable parameter is the output, which we will explain in the next page. Let us take our NCF dataset where we would like to classify a scenario based on their behavior. On the basis of multi-label classification, each scenario could distribute in one of the behavior categories. Accordingly, each fuzzy input variable can be assigned with one category. Therefore, the label dataset can be described by each pattern of signature in unique value. Consequently, the dataset should contain the label values of data points from each class label. Labeled NCF dataset is required to train and evaluate the malicious behavior. Let's move right now to the machine learning versus anomaly-based intrusion detection. Machine learning methods can be used for anomaly-based intrusion detection. The model provided by the supervised learning process can make predictions on new data instances K, nearest neighbor, KNN prediction is a non-parametric method dedicated to the classification. For the essential principle is classified by a majority vote of its neighbors from a training sample, with the sample value being assigned to the most common class among its K nearest neighbors. Using cross-validation, we build K different models. That is why we can be available or more able to make predictions on all of our data. We split our dataset into K10 parts. Then we build 10 different models. Each model is trained on the 9 parts and tested on the 10th. And our first model is trained from part 1 to 9 and tested on part 10. Our second model is trained from part 2 to 10 and tested on part 1, and so on. In this study, the experimental measurements of some important performance metrics of MANET used to mark the features of the network in case of AODV with non-malicious nodes and AODV with malicious nodes. To get a conclusive pattern of intrusion for each of these attacks, and in order to identify the models relevant to the different malicious nodes, the normal profile is collected with the absence of malicious node, and the attacker profile is created by simulating the malicious nodes in MANET. A purpose: we implemented and modified the supervised machine learning algorithm, which is applied to determine the most optimal dataset. We split the dataset into training and testing data with a 90-10 split. We were comparing the total accuracy of the models using NCF dataset and labeled NCF. The accuracy of the training reached 94%, higher than that of prediction accuracy on only KNN classifier or fuzzy inference system. That is, the accuracy is 92%. We can be easily seen that the proposed method demonstrates better performances In some attacks categories, inaccuracy varies between 0.87 and 1. In this paper, we carried out an analytic simulation study to generate scenarios of some of these attacks. The main contribution is an integration of a typical dataset. We propose an approach to collecting traffic data containing normal and malicious behavior in order to benefit from the best performance of labeled dataset. We determine the fuzzy relevant features. Future research will provide a more comprehensive attacks behavioral database as well as behavior patterns to enable anomaly detection. We plan also to extend the parameters used for identifying intrusive acts to reduce false detection rates. Besides, we intend to expand our experiments to include more complex network scenarios and traffic patterns. So thank you everybody for your attention, and for any questions about this paper, please contact us by email rahma.ilmedib@mars.rnu.tn.